Hello humans! Welcome to the less trained channel on the internet. Today I think it will be fun to explore some AI algorithms and see if we can use them to create some art. So, are you ready to watch a video in which I have
absolutely no idea of what I'm doing most of the time?
If your answer is yes, just keep watching. If your answer is no,
you're a really bad person.
But hey, it is too late now, you have to watch it anyway. I'm Artificial Marvin and you're watching The Filter Effect. So, as usual, let's start doing some research on the internet, to get some ideas going, to find some interesting algorithms, and to see what people are doing with AI art. As expected, I found some artworks using the very popular style transfer and deep dream algorithms, and some really interesting generative painting. But the thing that actually caught my eye was the new beta app of NVIDIA. It seems that this new app, called NVIDIA Canvas, has drawn the attention of many artists, especially on YouTube. I already knew this project since the paper was published, and it was called with the less attractive name of NVIDIA GauGAN. That is actually the name of the algorithm developed by the NVIDIA team. Basically, this code lets you draw some basic shape, and it uses the resulting image as a map to generate an almost photorealistic image. So the idea is to use the GauGAN architecture to generate some artwork. The thing is that at the moment there are lots of YouTube channels that are doing this kind of video. They use the NVIDIA Canvas as a drawing tool, drawing on the app's input canvas and generating beautiful realistic landscapes. For this reason, I thought to go a step further, using the original algorithm with code, in which I can, for example, use a different learning dataset in order to have more control on the output image. For example, maybe I can get something different than landscape, or maybe I can tweak the code to automate the generation of the input map in order to have a more complex output image. And that is most likely what I'm going to do, because training an AI is extremely time-consuming and requires a lot of effort in preparing the dataset to be used. As always, I will share only my thoughts about this process. So for those that aren't familiar with coding, don't worry, I'll try to be as clear as possible. So, searching a bit, I found some really interesting stuff from my project. Here we have some interesting algorithms, but before trying these algorithms, I wanted to play a bit with these websites in which you can doodle something and they generate an image with the AI. Here we have a Chimera generator, and here we have the NVIDIA GauGAN, in which you can create landscapes. So, let's play a bit. And yeah, I got a mix of weird results and some interesting ones. I also tried some style transfer on some artwork I did before, and a really cool AI that can generate an image with a text description as an input. And I got some really scary but at the same time really interesting outputs. After that, it was finally time to start with the real deal. And so I began to set up all the code and all the dataset needed for the algorithm to work. I decided to start with a different dataset from the one used by the NVIDIA Canvas, because it was the most complete one, which let me generate a wide variety of images along with the landscape images. Okay, so I tried to test the SPADE NVIDIA algorithm, but it didn't work. So I think that the problem is in the library I'm using. I'm using the newest library. I think that downgrading the library to an old one, the code should work. So let's hope it works. It took some time to make it work, because the code was giving me some issues and kept crashing. In the end, it was just a matter of installing different versions of some libraries it was using. So the first test was a success. The code managed to generate some credible photorealistic images using just the map images in the test folder. After that, I started researching a list of all the labels used to generate the images. And at the same time, I was a little confused about how the code was actually working and how I should have changed it to make it work the way I intended it to work. In fact, I still didn't know exactly why there were two label maps, a colored one and a grayscale one. I just assumed that the grayscale one was the way to go, because it was placed in the input folders. But still, I had no idea why there were three different folders for the input. So I just kept going, trying random things, to see what worked and what didn't. Here I have prepared a processing sketch with all the labels required by the algorithm, and now I'm going to try inputting this image. And also I have prepared in Blender a little scene, because I want also to test if I can get a little animation with it. To test the code with the new map and to be sure to use the right labels, I just copied the colors from one of the test images using GIMP, but
obviously it didn't work.
okay, so it's been a couple of days, but I think I finally got the code working. The problem was that the code was asking an original image to test against the generated image. But in my workflow, I didn't want it. I just wanted a sketch to generate my final artwork. So I had to hack a little bit the algorithm, but it seems now that it is working fine. So, after a lot of debugging, I noticed that, for the code to work, for some reason it needed to have the same file copied in all of its input folders, even if the code could actually work just with the maps in the labels folder. I could also change the code to check only one image as input.
But you know me.
I'm lazy.
Still, my code wasn't working, so I decided to check the test images against my generated one. And it came out that the code was looking for an image with a grayscale color space, and I was using one with an sRGB color space.
A color space is a defined range of colors. The easiest way of visualizing it is to think of a box containing all the possible colors that can be produced by mixing the three primary colors of light, red, green and blue. Well-known color spaces include sRGB, Adobe RGB and ProPhoto RGB. In our particular case, we are dealing with the grayscale color space that is represented just with a one-dimensional set of values ranging from black to white. You can visualize it, for example, as a linear gradient. The sRGB color space instead is represented on a two-dimensional set of values, and you can visualize it on a plane.
So basically, the code was yelling at me that the data I was inputting were too large in comparison to the expected ones. And here I had another problem. It seems that processing isn't capable of exporting grayscale images, so I had to add another step using ImageMagick, a library used to edit images, to batch process all the images generated in processing and convert them in the grayscale color space. After that, the code was finally working, but I still had a big problem. I still didn't know what colors I could use for the labels to work. In fact, using random grayscale values was still causing the code to crash occasionally. So after a little research, I found a list of all the labels contained in the dataset. And so I assumed that my problem was that I was using too many shades of gray to represent this label. In fact, on the sheet there were only 91 labels, and I was picking on the full 256 shades at my disposal. So after that, the code began to work, and I actually have been able to generate an image displaying all kind of food that was included in the dataset. So once the code was working, it was finally time to make some art. And so I generated a lot of weird abstract portrait using processing. And after that, I started generating a visual map with all the labels, because the next step was using Blender to block some geometry, which I would have used to generate a little animation. And obviously, when all seemed to be alright, another problem gave me an headache. Now the code was generating some really grainy materials for each object in the scene, and the result seemed to have nothing to do with the labels I used. So after a quick inspection of the map saved from Blender, I noticed that the software's way to handle colors when exporting an image was not so reliable. In fact, inspecting some near pixels of the same color, the values I was getting were varying by a couple of gradations. With the naked eye, there were no difference at all. But for example, to represent a person, the algorithm was switching between a person, a bicycle, a car, and a motorcycle every other pixel. That finally explained why the generated images looked so grainy. So I spent a lot of time playing with the exporting parameters of Blender, with no apparent result. Nothing seemed to work, but finally, in the end, I solved it by maximizing the compression of the image. These are the final results I got using processing. And here it is, the animation I got using Blender. I think that this technique generates a lot of interesting and pleasing results. What do you think? If you have any comment or suggestion, please write it in the section down below.
What do you call a fish with no eyes? A fish. What happens if you spit out a light bulb? You're delighted. I once farted in an elevator, which was wrong on so many levels. Why programmers don't go to parties? 'Cause they can't find the dress code on Stack Overflow.
If you liked this video, please give me a like, subscribe to this channel and hit the bell button. Until the next challenge, as always, thank you for watching. Bye humans!